Hey, fourth graders, looking at your math boxes that were assigned yesterday and working through them. This is a multi-step problem. We know how much. I mentioned that the first thing we needed to do when I went over them yesterday was to add up the kilograms for the bear statues and add up the kilograms for the gorilla statues. Probably the easiest way to do it. So when we add up the bear statues, we'd have 35, 47, and 62. Add those up. And then for the gorilla statues, you have 68, 82, and 91. So if you haven't done those, do that now. On this one, 5 and 7 is 12, 2 more is 14, so I put my 4 down, carry my 10. I always look for ways to make 10 if I can. 6 plus 4 is 10, 3 more is 13, 1 more is 14. So the bear statues are 144 kilograms. The gorilla statues, 8 and 2 is 10, 1 more is 11. Put my 1 down, carry my 10. 1 and 9 is 10. That makes 18. 6 more is 24, so I get 241. That's just the first step. And by the way, that's 241 kilograms. Now what we need to do is we want to, because it wants to know how many more grams do the gorilla statues weigh than the bear statues. What I would do now is I would find the difference, because if it's asking how much more, then what we're doing is 241 minus 144. So go ahead and do that if you haven't. And here's how you'd work through that. You can't go 1 minus 4, so you cross out the 4, you make that a 3. This becomes 11. 11 minus 4 is 7. You can't do 3 minus 4, so cross out the 200, make it a 100. This becomes 13 tenths. 13 tenths minus 4 is 9. You can just think of it like a 13 minus 4. 1 minus 1 is 0. So you get 97 kilograms. The gorillas weigh 97 kilograms more than the bears. But that's not the last step, because if you look at our answer, all of the answers are in grams. And it wants to know in grams. So when you change kilograms to grams, you take those kilograms and you're going to multiply by 1,000. And you can just forget about the zeros for a second and take a look at the digits. We have a 1 and we have 97. Just do that problem. 97 times 1. That's 97. Then you have 3 zeros, which would give you 97,000 grams. A was your best answer there. Alright, when going through this yesterday, I did the first 2 of them in box 2 for you. I'm going to make them bigger so you can see them even better. Slide it way over there. The answer to the first one was 459. I did that yesterday. And the answer to this one was 345. I asked you to just do these 2. So the first one you're doing 650. The rule is times 3, so we're going to multiply that by 3. And you start with the hundreds. Now that 6 is actually a 600. So if you look, there'd be 2 zeros. I put those down right away so I don't forget about them. And now I can just do 3 times 6, which is 18. So 3 times 600 is 1,800. Now this 5 is actually a 50. There's 1 0 there, so I'm going to put it down right away. And I'm going to do 3 times 5, which is 15. 3 times 0 is 0. I don't have to do that. 0 and 0 is 0. 0 and 5 is 5. 8 and 1 is 9. And the 1,000. So I get 1,950. Now this next one was probably the hardest one for you. It's a big division problem. And the biggest thing when you're doing this is just to take your time. And we have to think multiplication. It's actually about multiplication. So 2,178, and I said you have to divide it by 3 because we're going back this way. Another way to think about it would be 3 times something equals 2,178. That's a lot of work. And we might have a hard time thinking about that. But that's essentially what we're doing anyway. Because what we're looking at here, can the 3 go into 2? No, it can't. So instead of looking at just the 2, we're going to look at this 21. I'm only underlining that in green so that you know where we're looking. And what we're thinking is, how many 3's can go into 21? Or what times 3 gets us close to 21 without going over? It can equal it. If it equals it, that's awesome. And in this case, it will. 3 times 7 is 21. Now, because I'm working with a 2-digit number, and 3 times 7 is a 2-digit number, I can write 21 like that. I add on my zeros. 3 times 7 was 21, but 3 times 700 will be 2,100. And I subtract. 8 minus 0 is 8. 7 minus 0 is 7. 1 minus 1 is 0. 2 minus 2 is 0. So we're down to 78. And now what this becomes is, how many 3's can go into 78? Well, that's a lot of work. This time, we're just going to focus on the 7. And the step that you should do, if you're trying to do this on your own, is to think, what times 3 gets me close to 7 without going over? And that answer is 2. 3 times 2 is 6. Because we're working with the 7, I put the 6 underneath it. Put a 0 in, put a 0 in, and subtract. 8 minus 0 is 8. 7 minus 6 is 1. Hey, now we're getting down to some small numbers, and we're looking at what times 3 is 18. You might need to count up, or you could have tried 5. But the answer is 6. 3 times 6 is 18, and you subtract. And this is where your answer would be. 700 plus 20 is 720, plus 6 is, I'm going to write it in a different color because of the blue, 726. Now, the third, or the last problem here, the fifth problem, was an optional one. If you get it, your answer should have been 2,865. I'm not going to work through that in the interest of time, but you can check your answer there. So now, moving on to box 3. Pretty easy one. At the movies, we had Naomi and Paulina, and they shared one bag of popcorn and ate it all. Paulina ate 2/5 of a bag of popcorn. How much did Naomi eat? What I pointed out to you yesterday is that a full bag would be 5/5. We don't know how much Naomi ate, but we know Paulina ate 2/5. So 2/5, 5/5 minus 2/5 is what you should do. And we know that when your denominators are the same, they're going to stay the same all the way through. So we'll have fifths. 5 minus 2 is 3. Your answer for this should have been 3/5. Okay, probably the most time-consuming one maybe was doing these division problems. I'm going to do the first one here. There were remainders for both of these. So if we have 358, that's not going to leave me enough room on the side here to write in my work. So 358 divided by 4. There we go. Okay, so again, what you start with is the hundreds place in this case, because that's the biggest place value we have. Can 4 go into 3? No. If you count by 4s, 1 4 is already bigger than 3. So we're going to look at this 35. And what you should be thinking is, how many 4s can I count by and not go over 35? Now here's what I know. I know that 4 times 9 is 36, so that's too big. That means it has to be 8. Because if 4 times 8 or 4 times 9 is 36, 4 times 8 is going to be less than that. 35 is really close to 36. 4 times 8 is 32. Now, when we have this open space, we add a 0 to both places, because 4 times 8 is 32, but 4 times 80 will be 320. 8 minus 0 is 8, 5 minus 2 is 3, and then you're left 3 minus 3 is 0. So this actually helps us with this, because if 4 times 8 is 32, then I know that 38 I could do 9. 4 times 9 is 36. 8 minus 6 is 2. 3 minus 3 is 0. Here you've got your answer. It is 89, remainder 2. And this one, you don't have to worry about the remainder because it's just simply a division problem. You can write it like that, 89, remainder 2. You don't have to do anything with it because it's not a word problem. So, here in letter B, there are 587 pencil sharpeners, and we're putting those into boxes that hold 8. And when I take a look at this, I look at the 5 first. Can the 8 go into 5? No, 1 8 is bigger than 5, so that means we have to work with the 58. Now, you know you can't do 8 times 10 because 8 times 10 would be 80 and that's bigger. So some of you might have wanted to start with 8 times 5. 8 times 5 is 40 and then you could subtract. If you did it in the largest possible way, then it's 7 because the rhyme that you guys know or the march that you guys know is 5, 6, 7, 8. 56 equals 7 times 8. Put a 0, put a 0. 7 minus 0 is 7, 8 minus 6 is 2. And now we're looking at 27 divided by 8. Or how many 8s can you count by without going over 27? And the answer to that is 3. 8 times 3 is 24. 7 minus 4 is 3, 2 minus 2 is 0. There's your whole number, 73. Remainder, 3. Now, what we need to do here is we need to, and I mentioned this when I went over these yesterday, you need to evaluate what to do with the remainder. Because as we're doing this, you have to kind of picture this. You have 587 pencil sharpeners and we're putting them into boxes of 8. So the first box comes 1, 2, 3, 4, 5, 6, 7, 8. Push that box over. 1 box full. Another 8 go into this box. That's 2. So each time out of these 587 pencil sharpeners, I'm taking 8 and I'm putting them in a box, and I'm going to keep putting them in boxes until they're all in boxes. 73 boxes later, I have 73 full boxes of pencil sharpeners. Each of those 73 boxes have 8 pencil sharpeners in them. But I still have these 3 pencil sharpeners. The remainder 3 represents the pencil sharpeners that are just sitting out there. They're not in a box. They were on my original pile of pencil sharpeners. And what do I do with them? Do I report it as a fraction? Do I need 73 and 3 ace boxes? You wouldn't report it that way. They want to know how many boxes do you need. Would you ignore them? You could, but we want all the pencil sharpeners in a box. So if we ignore them, we're not doing that. What you needed to do here was round up. I need a 74th box because I fill up my 73rd box, 1, 2, 3, 4, 5, 6, 7, 8. I push that away and there's 3 more. I take my 74th box, 1, 2, 3 pencil sharpeners. Is the 74th box full? No. You could put 5 more in there. But without that 74th box, I'm not getting all the pencil sharpeners in a box. And that's really what this was down here. It's just explaining why do you need that 74th box. Okay? So I'm not going to write that out. All right, guys. That's it for math today. Talk to you later.